All right, this is the Coordinate Geometry 3 lesson. Objectives are to discover the results of a composition of transformations on the coordinate plane, learn to combine two transformation rules to get a single transformation rule that would take the original figure directly on the second image, determine a transformation rule to transform a second image back to the original figure. And vocabulary is compositions of transformations. Launch, solve. Try to find more than one solution. Triangle ABC with vertices -1, 0, B4, 0, C2, 6 is translated by the rule xy, x minus 6, y minus 5. Then its image, A prime, B prime, C prime, is translated by the rule xy, x plus 14, y plus 3, to get A double prime, B double prime, C double prime. What single translation is equivalent to the composition of these two translations? Well, again, I'll write this in vector form. First one is -6, comma -5. Second one is 14 and 3. So we could just add these together and get, let's see here. That'd be 8, comma -2. And that would be the same. Second one is, what single translation brings second image, A double prime, B double prime, C double prime, back to the position of the original triangle, ABC? Well, I guess I'd just be undoing that. Let's see. Well, solution. We can draw it, and we can see that the single translation, x plus 8, y minus 2, that's what we got, moves it directly C double prime 10, 4. Okay. So each vertex is moved left 6, then right 14, down 5, and up 3, so the equivalent would just be to add them together. Reversing the steps, just reverse the translation vector to bring it back. In earlier lessons, you reflected, translated, and rotated polygons using ordered pair rules on the coordinate grid. In this lesson, you will learn to transform a figure and then transform the image of that figure when you apply one transformation to a figure and then apply another transformation to its image. The resulting transformation is called a composition of transformations. Let's look at an example of a composition of two translations. Okay. Example B. Given triangle PQR with vertices P, Q, and R reflected across the y-axis to create an P prime, Q prime, R prime, then reflect that across the line y equals 1. Okay. What is the transformation rule, xy, so that transforms P into P prime, Q prime, R prime? Well, you want to reflect it across the y-axis, and that means that, like, if we reflect across the y-axis, that would make Q prime would be right here. P is 1, 2, 3, 4, 5. So 1, 2, 3, 4. It's P prime. It's right there. R prime would be R prime. A little triangle here. There we go. So it looks like all that's happening really is that the x coordinate changes sign and the y coordinate stays the same. What are the coordinates of the new P prime, Q prime, R prime? Well, they are just going to be 5, 3, 3, 6, 6, 5. Okay, what are the coordinates of the vertices of P prime, Q prime, R double prime? All those. Well, we want to reflect it across the line y equals 1. So across this line. So P, let's see here, 1, 2, P double prime. R double prime. Q double prime. And there we go. What is the transformation rule XY that transforms P prime, Q prime, R prime onto P double prime, Q double prime, R double prime? Transformation rule, let's see here. How about, well, let's see. P prime is 5 and 3. P double prime is 5 and minus 1. What about Q? Q prime is 3 and 6. Q double prime would be 1, 2, 3, 4. 3 and 4. So maybe like, looks like the X value stays the same. The Y value appears to be changing sign, but also being like 2 less than the number. So like, maybe like take your Y coordinate and subtract 2 and then change the sign. Does that work for R prime? Yep, sure does. That's it. There it is. What is the single transformation rule that takes P, Q, R into P double prime, Q double prime, R double prime? Well, that's going to be negative X, comma Y. So all we need to do is do negative X, then negative Y minus 2, and we have our single rule. So I think over that there. And then, yep. There we go. Next, let's look at the composition of rotation and reflection transformations. So given triangle DEF with vertices D, E, and F, reflect triangle DEF across the line y equals x would create D prime, E prime, F prime. Rotate DEF 90 degrees clockwise about the origin to create D double prime, so on and so forth. Reflected across the x-axis, and we're doing 3 of them this time. Okay. What is the transformation rule XY that transforms DEF into D prime, E prime, F prime? It's across the line y equals x. So that's reflecting it across this line. And so that's going to be E prime. And you have F here. Hold on. There we go. F prime, 2, 3. D prime. Get this. Yep, that's it. So what rule is it? Well, I can see that D is x is 1, 2, 3, 4. So minus 4. Y is 2. D prime, that's actually 2 minus 4. So it looks like just switch the y and the x. And what about the coordinates of that are given over here, so on and so forth. So first step is to draw a triangle DEF on a set of axes and relocate its vertices by reflecting triangle DEF across the line y equals x to get D prime e from f prime. Earlier you discovered that a reflection across the line y equals x switches the x and y values of each ordered pair, thus it is equivalent to the ordered pair rule. Earlier you discovered that a rotation 90 degrees clockwise is equivalent to the ordered pair rule y minus x. Relocating the vertices of triangle DEF using the ordered pair rule gives the vertices D double prime 2, 4, E double prime 0, 1, F double prime 6, 0. And then earlier discovered a reflection across the x-axis is equivalent to y, x, minus y. Relocating the vertices is shown there. And if we need to combine them, put them all together, and we get that. What will happen if you change the order in which the two lines of reflection are used? What will happen if a translation is followed by a reflection along a line in the direction of the translation? What will happen if you change the order in which the two lines of reflection are used? The direction of rotation changes. So if a translation is followed by a reflection, it's called a glide reflection. Draw any triangle CQR, then translate your triangle by the transformation rule. Now reflect the image across the x-axis. What is a single transformation rule that makes the original figure into the final image? And we see it's x minus 4, negative y minus 1. Name a single translation vector that can replace the composition of these three translation vectors. Name a single rotation that can replace the composition of these three rotations. 45, then 50, then 85. Oh, that's 180 degrees. Cool. That is CG3.